Well, we are continuing with the chapter of oscillator or oscillations as well as S.H.M. In this particular chapter, we have discussed earlier about the various definitions like periodic motion, the oscillatory motion, the simple harmonic motion. Now, these are to be applied in the various concepts. So, our today's discussion will be from the energy of harmonic oscillators and some examples based on S.H.M. So there are certain examples based on general equations of S.H.M. The point to remember is that general equation of S.H.M. is either a sine function or a cosine function, but it should not be a square function. So normally the equation of S.H.M. is y is equal to a sine omega t or y is equal to a cos omega t. Omega t in both the equations is supposed to be the phase angle and A is supposed to be the displacement amplitude. We can continue the various calculations with consideration that the general equation is in the form of sine omega t or the general equation is in the form of A cos omega t. So, general equations can also be explained in terms of phi. Like one of the equation is y is equal to a sine omega t plus minus phi. That is, in one equation we write plus sign and in other equation we write the negative sign. Phi is supposed to be the phase difference and phase difference is taken as 2 pi x over lambda. Wherever we write lambda, that is the wavelength, and lambda can be taken as velocity into time period. So we can compute these values in the general equation and we can reach to the various conclusions for the calculation point of view. Another important thing in this portion of S.H.M. is that when we say that y is equal to a sine omega t plus phi, it means that wave is moving in the negative direction of x-axis. When the phase is positive, it means wave is moving in the negative direction. And when the phase is negative, then the direction of propagation of wave is in the positive direction of x-axis. These are the two basic conventions we have to use in S.H.M. So we proceed with the main concept. We have come to the first question, that is two linear S.H.Ms having equal amplitude. Whenever we use this term amplitude, we are referring to the coefficient of sine or cosine function. And the inner portion in the bracket, that is supposed to be the phase angle. So now, in our question, there are two linear S.H.M having equal amplitude. So amplitude is not changing, but frequency is omega and 2 omega. So second frequency is double of the first one. They are superimposed, means either crest is falling on crest or trough is falling on trough, or crest is falling on trough and trough is falling on crest. So the context is frequencies are omega and 2 omega are superimposed on a particle in x and y direction. If initial phase is pi by 2 between the two S.H.M, the resultant path of the particle will be how much? That is what we have to calculate. To start with the calculations, first of all we write the general equation of S.H.M. That is found to be x is equal to a cos omega t. Now it is not necessary that we should take a cos omega t. However, we can take a sin omega t also. However, these functions must not be the square functions. Now, we have taken the displacement as a cos omega t. The coefficient of cos omega t is a and a is supposed to be the displacement amplitude. Omega t is supposed to be the phase angle. Now, equation of motion in y direction. Now, that is given as a cos 2 omega t plus pi by 2. That is in accordance with the question, because in one case the frequency is omega and in other case the frequency is 2 omega. Now what we have done, y is equal to a sine 2 omega t. Now this is we can take the trigonometric function here, that is cos pi by 2 plus 2 omega t, and we must know that cos 90 plus theta is sine theta. So we have taken y is equal to minus a sine 2 omega t. Now 2 sine, when we speak sine 2 omega t, we are referring to a formula of trigonometry sine 2a, that is 2 sine a cos a. So that formula we have applied here, and we come to y is equal to minus 2a sine omega t cos omega t. Now we have to eliminate time. So what we do is we take displacement equation. So in displacement equation, we write y is equal to minus 2a under root 1 minus x square over a square into x by a. And y square, then we do y square. So by taking y square, our function will become 4x square into 1 minus x square over a square. Now we come to the another question, that is equation of two S.H.Ms are given x1 and x2. Now the point to note is that x1 is totally in terms of sine and x2 is in terms of sine and cosine. In these two equations, we have to find the ratio of the amplitude and the phase difference. So phase difference is obviously phi, and phi is equal to 2 pi x over lambda. So first of all, what we have to do is that x2 is to be transformed into a single equation that is simply in terms of sine function, because at present x2 is given in terms of sine as well as cosine function. So this function is to be totally changed into a sine function. So how exactly we will do it? So you can check up the solution, that is x1 that is given to us, that we have written, x2 also we have written as given in the question. Then x2 is converted into the sine function. How exactly we have proceeded? That is sine 2 pi by t, sine 2 pi t means that is sine 2a. And trigonometrically, sine 2a means 2 sine a cos a. Similarly, we have taken cos 2a and we have computed the value of cos 2a trigonometrically, and our net function will become tan into sine 2 pi t cos pi by 4 plus cos 2 pi t sine pi by 4. Now this is a formula of trigonometry again, sine a cos b plus cos a sine b, that is sine a plus b. So we have taken the next step, that is xt, x2 is 10 sine 2 pi t plus pi by 4. In the above line we have applied the formula of, that is sine a cos b plus cos a sine b, which is found to be sine a plus b. Now we have got two equations, x1 and x2. x1, it is in terms of sine, x2 is also in terms of sine, and the coefficients are 5 and 10. So we have taken the ratio of amplitude, that is 5 over 10. It is 1 over 2. Now we have to take the phase difference. So we have to take the portion written along with sine in both the equation. So first of all, we will write 2 pi t plus pi by 4, and we will subtract from the second equation phase, that is 2 pi t plus pi by 4. Both are the same phases, hence they will cancel off and the phase difference will be 0. Now in our next question, a particle is executing S.H.M from the mean position at 5 centimeters distance. So S.H.M is being executed from the mean position, and when the particle moves about 5 centimeters from the mean position, acceleration at that instant is 20 centimeters per second square. Then value of angular velocity will be how much? That is, we have to find omega, angular velocity, that is v over r. So that concept we have to continue. So now it is frequency is given as omega square y. Omega is the angular frequency or the angular speed, and omega square is f over y. Now f is given to us, or we can say f over y, that is 20 over 5. So frequency is 20 and 5 is the displacement. So it will be 5 fourths. Omega square is 4. We take the square root and it will be 2 radians per second. In our next question, the maximum velocity of a harmonic oscillator is alpha and its maximum acceleration is beta. Its time period will be how much? So first of all, it is very important to know what basically is the maximum velocity. Well, in the function of velocity of a harmonic oscillator, there is a concept, that is, there is a function called A omega, and that is supposed to be the velocity amplitude, or sometimes we say it as the maximum velocity of the harmonic oscillator. Similarly, when we consider the acceleration of harmonic oscillator, the function will be of the form of A omega square. So A omega square is the acceleration amplitude, and otherwise it is called the maximum acceleration. So it means that one of the equation will become A omega is equal to alpha, and other equation will become, that is, A omega square equal to beta. By using these equations, we have to estimate the time period. So as I have explained, the two equations we have taken, V maximum and A maximum, in terms of alpha and beta, and we have marked them as equation number 1 and equation number 2. Now second equation is divided by first equation. So we will find that beta over alpha will become equal to omega, because one of the number of omega will cancel off. So omega is beta over alpha. Now time period we know, time period is 2 pi over omega, and omega must be computed beta over alpha. So our net function will become t is equal to 2 pi alpha over beta. Now we come to the next question, that is periodic time of a simple pendulum is 2 seconds. When we use the term periodic time, we are referring to time period. So it is 2 seconds. It can travel to and fro from equilibrium position up to maximum 5 centimeters. At start, the pendulum is at maximum displacement on the right side of the equilibrium position or the mean position. Now, to start with our question, first of all, we take the displacement equation. We find that displacement expression for S.H.M, that is given as x is equal to a sine omega t plus phi. Well, phi is the phase difference. In many questions, phi can be replaced by 2 pi x over lambda, and lambda can be replaced by Vt, velocity into time period. Omega can be replaced by 2 pi over t. So we can make a new function. However, at this stage we don't require it, and that's why we write simply a given function, that is x is equal to a sine omega t plus phi. The time period of pendulum is given according to equation t is equal to 2 pi over omega. Now, it is given as 2 seconds in the question. So, we have taken 2 pi over omega is equal to 2 seconds. 2 will cancel off and omega will be equal to pi. Now, amplitude of the pendulum A is 5 centimeters. This is given in the question. This is in the to and fro motion. The maximum amplitude is 5 centimeter. So, we again write the equation of S.H.M. That is, equation of S.H.M is 5 sine pi t plus phi. So, why we have written phi there? Because 5 is the amplitude and the coefficient of sine function is the amplitude. So, the equation, instead of a sine omega t plus phi, the equation will become x is equal to 5 sine omega t plus phi. Now at t is equal to 0, when we say t is equal to 0, it means that motion has not yet started. Displacement is given at t is equal to 0, and that displacement is 5 centimeters. So in the equation, we put 5 for the displacement and then we make calculations. So we write 5 sine pi into 0 plus 5. So pi into 0 will become 0, 0 plus 5 will be 5, and our net function will become sine phi is equal to 5 over 5, and that is 1. So sine phi is 1. Now which angle is equal to 1? For the angle, sine angle, that is phi must be pi over 2, that is 90 degrees. Therefore, y is equal to 5 sine pi into t plus half, and this can be taken as 5 sine pi t plus pi by 2, and y is equal to 5 cos pi t, because when we write pi by 2, it will be taken as 1. So our net expression will be 5 sine pi t.